Hello everyone, my name is Duke. So today I would like to present our research on the detection of inconsistencies in privacy practices of browser extensions. This research was done by researchers at the University of Michigan, including myself, Brian Tang, and Professor Kang Shin. So extensions are plugins in browsers to provide additional functionality to enhance user experience. For example, users can use an extension like Dark Reader to provide a dark mode for websites so that web pages appear darker to reduce the eye strain for users. However, extensions can access and leak sensitive personal information because they run on the same context as the websites. Therefore, extension stores started to require extensions to declare privacy practices in various forms. For example, in template-based dashboard disclosure and free-from privacy policies. It's important for extensions to ensure that their privacy disclosures to be consistent with their actual behavior. This is because any discrepancy between the dashboard disclosure, the privacy policies, and the behavior of the extension would be a violation of the Chrome Web Store developer program policies. And this may result in the removal of the extension from the store, causing serious damage to the extension developers. However, there is no warranty of consistencies between the stated practices and actual data collection. So the main research question of this paper is that, can we automatically detect the inconsistencies between the actual data collection and stated privacy policy of the web browser extensions? So we present XPriver, an end-to-end automated framework that can analyze the flow topology consistency of browser extensions. So it addresses three challenges: heterogeneous privacy disclosures, extraction of data flows, and granularity mismatch of data types. So the inputs of the system include the privacy policies, the dashboard disclosures, and the extension code. So the privacy framework first extracts the privacy statements from the privacy policy and the dashboard disclosure. It then extracts the data traffic from the behavior of the extension and then extracts the data flow from the key values in the data traffic. Finally, it analyzes the contradiction and the consistencies and outputs the contradictory privacy statements and the inconsistent data flows. So there has been a lot of work that analyzed the extension execution. However, they did not analyze the privacy policies and the inconsistencies. So they were limited to detect only the simple leakage of sensitive user data. So as the first step, our framework analyzed two forms of privacy disclosures: the free-from privacy policies and the template-based dashboard disclosures. So for the free-from privacy policies, we extract the privacy statements using pipelines, a state-of-the-art automated framework for analyzing privacy policies. It uses NLP techniques like using the semantic role labeling to extract the data types and the receiver for each privacy statement. So for example, given some correlation, share, or use verb, it extracts the semantic arguments and extract data types and receivers. We also detect the sentences with extension mentions so that we can exclude any statements that are unrelated to extension, like for the website and the apps of the same developers. For the template-based dashboard disclosure, we extract the collected data types by analyzing the HTML of the extension description pages. So one of the main innovation of this paper is the extraction of the uncollected data types in dashboard disclosures. So let T be the set of the all data types, and C is the set of the collected data types as declared on the dashboard disclosure. Then the set of the uncollected data type U is the subtraction of C from T. For example, one extension may declare to collect only 4 data types: PAI, location, user activity, and website content. And there are 9 data types on the web store. Then the extension should only collect the 4 data types as they declare in their dashboard disclosure. and should not never collect any data types in the remaining 5 data types, including the web history, health information, financial information, authentication information, and personal communication. Our framework then extracts the data flow as follows. So we trigger the extension functionality by emulating user interaction on real and honey web pages. So we create automation that can emulate user interactions like mouse clicks, keystrokes, and shortcut key combinations. So we also design a honey web page specifically designed for illicit behavior of extensions. We then extract the traffic initiated by extension by analyzing the initiator of the JavaScript code stack to determine whether the network traffic was initiated by extension or not. And we use pattern matching-based binary classifiers to infer data types. So we support 4 context-free data types: web history, website content, location, and user activity. For example, we use exact match of page title and page URL to detect the page title and URL low data type under the web history high-level data type. We also look for the known values of the IP addresses and the region of our test-based server, like Ann Arbor, Michigan 48105, to detect the IP address and region low-level data type under the location data types. The precision of these classifiers achieved more than 93%. Finally, in order to detect the inconsistencies, we derive the unified ontologies of the data types, which determine the substantive relationship between the data types. For example, the page URL and page title are substantive under the web history. We then derive the inconsistency conditions, like the policy logical contradiction and flow to policy consistencies. We use this condition to detect the contradictions between the privacy statements in the dashboard disclosure and the privacy process, and detect the inconsistencies between the data flow extracted from the extension execution and the privacy statement from the dashboard disclosures. So the statements inside one privacy process and the inconsistency between execution of flow extension and their privacy process are not the scope in this research. So using the fully automated system, we conducted a large-scale study. We crawled on 134,000 extensions on Chrome Web Store on February 2022. And of these, 47,000 extensions contained dashboard disclosures, and 2.1 extensions had privacy statement extracted. We found that many extensions contain contradictory privacy disclosures. We detected 525 pairs of contradictory statements in 360 extensions with more than 27 million users. These are 17% of the extensions with extracted privacy statements, and the detection precision achieved 92% as verified by 2 others. As a case study, we found that the AdBlock extension with more than 10 million users contain contradictory privacy disclosures. So on the left-hand side, on the dashboard disclosure, they say that they will not collect or use user data, but on the right-hand side, on the privacy process, they say that they may receive the IP address of the user. So these are contradictory with what they say on the privacy disclosures. So in more details, in the privacy process, they say that when the AdBlock extension communicates with the server, they will receive the IP address, and they also say that after 6 months, they will receive the IP addresses from the log file and databases. So based on the privacy process, it's likely that they may collect and store the user IP addresses, and this is clearly contradictory with what they say on the dashboard disclosure. Even worse, we found many extensions that contain the inconsistent data practices. So we detected 820 extensions with inconsistent data flows with more than 84 million users in total. These are 82% of extensions with extracted data flows. And the detection precision achieved 85% as independently verified by 2 others. As a case study, we found that the Capital One shopping extension with more than 6 million users omitted the collection of web history. So on the dashboard disclosure, they declared to collect only 4 data types: PII, location, user activity, and the website content. So they should not collect the web history because the data type is not on the list. However, when we browse Amazon.com to shop for the shopping, then we found that the URL of the web pages we visited were sent to their tracking server at the track.capitalOneShopping.com. So this is clearly contradictory with what they say on the dashboard disclosure. We analyzed the inconsistency to check the root causes, and we found the following 3 potential root causes. First, extensions tend to declare a limited number of the user data types to reduce the time to publish on store. We found that 57% of inconsistent extensions disclose no user data collection or use. Furthermore, extensions might omit sensitive web browsing history data type to avoid being suspicious to users. We found that the most common inconsistent data type was the web history. And finally, extensions might not fully configure their analytics libraries to limit the data type they collect. We found that 14% of the data flows were sent to the Google Analytics or Sentry analytic libraries. So in conclusion, in this paper, we presented XPriver, a fully automated framework to detect the inconsistencies between the actual data collection and stated privacy disclosure of browser extensions. We found multiple extensions containing contradictory privacy disclosure in 360 extensions with more than 27 million users. And we found inconsistent data practices in 820 extensions with more than 84 million users. For more information, you can visit the project website at the Real-Time Computing Lab at the University of Michigan. Thank you very much for your attention.
Thank you.
Thank you. That was great. You had a very crystal clear example of not tracking that URL, and you can see that getting posted. You had on page 6, I think, a bunch of stuff like financial information, healthcare information. That's much harder to kind of quantify. Can you explain how you define those fields, and then did you use the same technique to see if that was in a header that got posted back to the source?
Yeah, so in this paper, we only support the context-free data types. For the other data types, they may depend on the context, like financial information. For example, the credit card can be either the website content, but in some context, it's the financial information. And also another difficulty is that the web browser extensions, not many of them collect the health information or the financial information. So they are our future work.
Hi, great talk. I had a question about, did you explore different configurations of the browser extensions? For example, maybe if you could configure certain settings of the extensions, that its behavior would change.
Yeah, thank you for the great question. So we use a default setting of the web extensions when we do the experiments. So in order to set the combination of the setting of the extension is very hard to do so because of the exponential number of the setting we can set. However, all of the detection here at the dynamic analysis, so that means we have the exact inputs that can reproduce the inconsistencies, so we minimize the false positive that we can detect. But the more we extend our framework to cover more settings, then we may detect more inconsistencies.
Hi, great talk. I have just a quick question that by any chance do you guys look at, some of the extensions as force users to just sign up first and then use their services? Or do you guys have any insights on that as well?
Thank you for a great question. So so when the extension forces the user to sign up, we have not explored the part yet because it's very hard to automate the sign up automation. So like we need to make some fake user emails and name and last name, etc., and detect the field we need to input. So we have not done the user sign up for extension yet. But they are in our future roadmap. Thank you.
Okay, thank you.
Okay, maybe last quick question. So based on this, what you've done, what would be the support you wish from browsers to reduce possibilities for this kind of inconsistencies? Maybe connecting policies to permissions or capabilities of extensions. What would be your insights here based on the experiments?
Yeah, so in terms of browser vendors, for example, Chrome or Google or Apple and even Firefox, so they can, so currently they already done the menu analysis, like checking the extension before we can submit extension to store, but I think using more and more sophisticated automated framework like ours, then they can check and even notify to the vendors. And also the vendor can adopt our technique to scan their own extension and reduce any non-compliance with the policy of the web store.
Okay, great. Thanks very much.
Yeah, thank you, Red. Thank you very much.